Let's talk a little bit about IPv6 Icmp and testing connections with it. So with IPv6 we have Icmp just like we do with v4. We also have a v6 version. And let's go through some of the comparisons of them. So Icmp is used for a lot of diagnostic purposes in IP, and we'll go through and use a lot of this as we go through these videos and do testing and diagnostics and such. You'll be using a lot of Icmp. Icmp v4 has some fields for destination unreachable. If it can't get to a network, it'll say 0 network unreachable, 1 host unreachable, 2 protocol is unreachable, or 3 the port is unreachable. So basically it'll say, I couldn't get there, here's the most likely reason why. v6 has similar destination unreachable messages. So we'll say these are destination unreachable. IPv4 has a time exceeded message where the packet can't be forwarded because the TTL reaches 0. Remember, we're talking about that time to live value that starts out high and it gets decremented each time. If it reaches 0, then it gets dropped and it doesn't get to its destination. IPv4 uses that. v6 is similar. When v4 gets to 0, it sends a time exceeded to the source. So whoever was originating that traffic, it'll make its way back there and say, hey, I couldn't get there, time exceeded. So v6 has that same idea. It has this time exceeded, but it does not use a TTL. It uses a hop limit field, which is basically the same idea, but they just renamed it. IPv4, we have a redirect message. It notifies the host that a better route is available, so you can, and you know what, I'll write down time exceeded. Almost the same. We also have that redirect message. And so it notifies a host that it can go somewhere else, so you can redirect things to other routers if you wish. v6 has that same thing. Also, v6 has 4 new protocols, and those are part of what we partially already discussed with the neighbor discovery. Protocol. And part of the neighbor discovery protocol, we have that router solicitation, the RS, remember that. We have the router advertisement. We also have 2 new ones that we haven't discussed, neighbor solicitation and neighbor advertisement. So router solicitation we talked about. When a host wants to use Slack, the host will send a router solicitation message looking for its configuration. In return, it'll receive a router advertisement sent by the router, and it'll provide that prefix information and such. Neighbor solicitation and neighbor advertisement are used to used for address resolution and duplicate address detection. So it's similar to ARP, which we'll talk about, address resolution protocol in IPv4. Is used to determine the MAC of a destination. So in order to, and we'll talk about this in a next video or so, we'll talk about how when we get to the physical connections, we need some sort of address to get to the other side, because you're not always on a connection that only has one other device connected to you. You may, for example, Ethernet was designed around a bus architecture where we have a bunch of devices interconnected. So if you're sending something from here over to here, you need to know this guy's address, or else it might go to this one instead, or this one instead. So you need to know on the physical infrastructure what that address is, and that's what that MAC address is. So neighbor solicitation and advertisement do that similar functionality as you would have in IPv4. the neighbor solicitation will be sent to the solicited node address, and the advertisement will be sent in response with the MAC address. To perform the duplicate address detection that I mentioned, remember we're making up our addresses sometimes. So in order to make up our address, we want to make sure we don't step on somebody else's toes. So in order to do that, the device will send out a solicitation with its own IP address as the target. It'll go out to everybody, and then if a device has it, then a advertisement will be sent back in response saying, hey buddy, I already have it, try again, basically. So that's the basic idea of ICMP, and in order to utilize ICMP, two famous commands are out there that we can use. We can use ping and traceroute. So if you've never used this, they're very nice commands. You can ping something, and we're going to do the IPv4 version here, but we can ping something and it'll respond. So we're sending ICMP packets out to that destination, and the application ping on my computer here is timing it, and how much time it takes to get there and come back. It displays that information to me, whether or not I lost any data, anything like that. We can also ping our local loopback. Remember we were talking about that. On IPv4, it's this. If I want to ping it on IPv6, it'd be :1. And since this is Windows 7, I have IPv6 running right now. So that does actually work. You can also test connection to other devices, like I mentioned. You can test not just out to the internet, but you can test your local network as well. It's useful for diagnosing your business architecture. If you're having some sort of problem, you can ping your way out and kind of figure out where something might be going wrong. So I could ping my local router or something like that. Another function is traceroute. So we can traceroute an address. Oops, sorry, I was thinking Linux. So in Windows it's traceRT, in Linux it's traceroute. But what we can do is trace that address. And what the trace does, and I wonder if I can make this a little, no I can't. What it'll do is it'll send an ICMP packet out with a TTL of 1. It'll hit the first router. The first router will say time exceeded and send it back. We'll do it again with a 2. It'll go through that first router, hit the second router, it'll say time exceeded, send it back. It'll do a TTL of 3, get it through the first 2 routers, make it to that third one, he'll send the time exceeded back. That's how the traceroute actually works. It sends a series of ICMPs starting at a low TTL value and increasing each time. And each time it receives a time exceeded packet, it will then get some sort of response, and usually it'll also resolve its address we see here and that. So by doing so, we're able to determine what routers are out there, and potentially, what IP addresses they are, what what the DNS name might be. Sometimes you can determine what physical location you're in. There's Philadelphia. Sometimes you'll see New York City pop up, things like that. You can also tell what people's networks you're on. So like there we're on Verizon. Sometimes you might see like XO, or you might see MCI or Sprint or something pop up there. And it'll give you an idea as to where you might have an issue. So, one of these could be spiking, for example, in response time. This will actually, by doing this increasing TTL value in our ICMP packets, will give us an idea as to which one was slow to respond. Because if you just ping something and it says, oh, your response time is 400 milliseconds, well, that's a cumulative. You don't know which one is causing that problem. So if you do a traceroute, you could potentially find out which one actually has that problem. So you can do that with IPv4 or IPv6. So v4 uses that TTL value, and v6 uses the hop limit. So it's basically the same idea. So remember, it starts at a low value and increases each time it sends a new ICMP packet out. And it uses that time exceeded packet in response to determine where those routers are and who they are, and then some information about them. It'll try to process that. So those are some diagnostics you can use, and we'll do more, especially in the routers. There's a lot of show commands and debug commands and such that we can use that we'll go through and discuss coming up.